You're tilting your head up to the night sky, hoping to enjoy the most glorious light show ever: red, purple, and green ribbons of the northern lights. Instead, you see ghostly white streaks illuminating the sky. They look uncanny and even a bit creepy. What's happening here? Scientists have recently spotted these weird lights mixed in with the usual colorful northern lights. These pale streaks show up alongside or inside the red and green auroras. But they aren't actually auroras themselves. Instead, they might be created in a way similar to Steve, a mysterious, mesmerizing purple light in the sky about which we'll talk later. Researchers are still trying to figure out exactly what causes these white glows, but let's start from the very beginning. Scientists in Canada noticed something strange while looking at pictures of the northern lights. Those images came from TREX, a special camera network designed to study the space environment near Earth. Unlike other cameras that only capture certain colors like red or green, TREX records full-color images, making it easier to spot unusual details. The space physicist, who was reviewing these pictures with a colleague, came across a weird grayish-white patch mixed in with the auroras. Curious about what it was, the team decided to dig deeper. After searching through years of TREX data, they found 30 similar white-streaked auroras captured between 2019 and 2023 over Saskatchewan, Canada. These mysterious white tendrils stretched for tens to hundreds of miles across the sky. Sometimes they appeared alongside the usual red and green northern lights. Other times, they showed up right after colorful auroras faded away. Recent spectral analysis has revealed that the unusual whitish glow appearing in the northern lights is caused by continuum emission. That's a type of light that contains a wide range of wavelengths, rather than the distinct red and green colors typically seen in auroras. Normal auroras occur when charged particles from the sun collide with Earth's atmosphere, exciting oxygen and nitrogen atoms, which then releases energy as specific colors of light. But the white glow behaves differently. It means that another process must be at work there. Interestingly, this white emission resembles the light produced by the already mentioned Steve, aka strong thermal emission velocity enhancement. That's an atmospheric phenomenon that appears as purple or mauve light, often with a green striped pattern called the picket fence. Unlike regular auroras, it doesn't produce blue light and happens further from the poles. Scientists found that the green stripes are brighter than expected and don't have any blue light from nitrogen. This means the energy of the particles creating the colors is just right, not too strong. It means these particles aren't coming from space because they would have too much energy to create these colors. Next, regular auroras form at high altitudes, while Steve occurs farther south, closer to the equator. Scientists believe Steve is created by an extremely fast-moving stream of charged plasma flowing through the atmosphere. As this plasma speeds through, it generates intense friction and heat, causing particles to glow. This is a completely different mechanism than the one behind auroras. To really figure out if this theory is correct, scientists think they need to send a rocket into Steve, or its associated picket fence, to measure the electric fields and the exact conditions that create these phenomena. Getting direct measurements will be tricky though, since Steve doesn't happen all the time. Still, there's a good chance they can study enhanced auroras, which sometimes have similar colors to Steve and are more common. These enhanced auroras are also thought to be caused by electric fields. Speaking of the newly discovered white patches within auroras, they may also be caused by a similar heating process going on in the upper atmosphere. However, researchers are still unsure what could be driving this heating, or why the white emissions appear in some parts of the sky, but not in others. In some cases, the pale streaks appear with bright auroras, while sometimes they emerge in areas where auroras have just faded away. Although the white auroral emissions and Steve share certain similarities, their shapes and behaviors are quite different. Steve looks like a smooth, well-defined arc, and the white patches in the auroras are scattered and irregular. It means they're not exactly the same phenomenon. However, they could be linked to similar chemical or atmospheric processes. If this is true, it might allow scientists to investigate how plasma flows interact with Earth's upper atmosphere. But weird white glows aren't the only bizarre phenomenon appearing in the sky above your head. Scientists at the Indian Astronomical Observatory have recently captured something rare, a red aurora known as a stable aurora arc, aka SAR. It appeared during a strong geomagnetic storm. Unlike regular auroras, which happen when charged particles from space collide with Earth's atmosphere, SAR arcs form in a completely different way. Instead of coming from space, they show the movement of heat energy within Earth's atmosphere. This energy comes from Earth's ring current system. That's a massive flow of electric currents that circle the planet. During the storm, this system became highly charged, leading to these rare red arcs appearing in multiple places around the world. So, how do auroras like this happen? The sun constantly emits charged particles, which disturb Earth's magnetic field and upper atmosphere. This solar wind interacts with Earth and triggers breathtaking light shows. In the northern hemisphere, this phenomenon is called the aurora borealis. In the southern hemisphere, it's known as the aurora australis. The way the sun's magnetic field interacts with Earth's determines the intensity, color, and brightness of these auroras. Plus, the colors of auroras depend on the gases that are excited. Green is from oxygen, purple or blue is from nitrogen, and red, a much rarer color, comes from high-altitude oxygen. Now, beside these usual colors, there's something much less known, the black aurora. This one's pretty mysterious, because instead of lighting up the sky with colors, it creates dark patches within the glowing auroras. The black aurora can show up in different shapes, like dark rings, curls, or blobs within the usual bright lights. Researchers using the Cluster spacecraft discovered that these dark areas happen when there are holes in the ionosphere, which is the upper part of the atmosphere. In these holes, electrons are shooting up into space. Normally, in bright auroras, electrons fall down from space, bump into particles in the atmosphere, and cause them to glow. But in the black aurora, the opposite happens. Electrons go up into space, creating a hole where no light can form. After a while, these holes fill back in and the usual glowing aurora returns. So you can think of the black aurora as a kind of opposite of the regular aurora. It's a temporary anti-aurora that disappears after some time. You might be wondering why auroras are more frequent these days than they were a few years ago. The answer is simple. Right now, the sun is in the most active phase of its 11-year cycle, known as the solar maximum. During this time, the sun produces more sunspots, which are dark, cooler areas on its surface caused by intense magnetic activity. The more sunspots there are, the higher the chances of powerful solar events like solar flares and coronal mass ejections, which can send bursts of charged particles toward Earth. NASA and NOAA predict that the sun will continue producing more sunspots and energy bursts, leading to more frequent and intense space weather events. Solar activity is so strong that it produces the northern lights, or aurora borealis, visible much farther south than usual, especially in May and October. The current cycle, called Solar Cycle 25, officially began in December 2019. Since then, the sun's activity has been steadily increasing each year. Scientists believe this solar maximum will last longer than usual because Solar Cycle 25 is relatively weak compared to past cycles. But it's actually a good thing if you want to catch more light shows. A longer solar maximum means more chances for strong solar storms and more opportunities to see stunning auroras in unexpected places over the next few years.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.